Okay, so I'll be giving the presentation on chemical engineering. I'd like to say I've got some robots that are playing soccer, but sorry, it's not really what we do. So what is chemical engineering? Well, chemical engineering covers the spectrum from raw materials through to processes through to final products. So chemical engineers are involved at all of these stages in producing the products which go into the marketplace. So some typical chemical engineering decisions are which reaction pathway should we use? Purification, how do we get a product with the level of purity that we need? Control, it's also electrical side of things, but how do we control the process and ensure that it's safe? How do we do things cost effectively? Byproducts, this is a big issue. The days where you can just dump all your byproducts in a landfill are over. What do we do with them? Can we reuse them in the process? Can we reuse them for something else? How do we design our processes efficiently? And how, particularly with things like carbon taxes, how do we reduce our energy? How do we work with OH&S? And what are community and cultural issues? So these are just some of the industries that chemical engineering and chemical engineers are employed in, including what you might think of as the standard industries of chemical and allied products, but also pharmaceuticals, energy, water. Think about water treatment. That's very much a live issue. How do you treat water to produce the quality that you require? Food and drink materials, and there's a big oil and gas is a big user, a big employer of chemical engineers, and then the emerging fields of biotech and obviously business and management consultancy. So there's a lot of diverse projects that you're able to work on. So these are just some of the companies which might employ chemical engineers. As I said, from the standard, what you would think of as the classical chemical engineering companies, a company like Orica, but to being widely employed in oil and gas, all of the liquefied natural gas projects, also paper, pharmaceuticals. There's a large employer base of different companies. So these are just some of the career paths that you might have. A process engineer, starting as a design engineer, management after some time, a research engineer, you find a lot of those around university, an entrepreneur, starting up your own company. Whoops. So what are the sort of salaries you can expect? Well, extremely good, and there's a lot of opportunities to travel. Okay, so what do we have? Well, common first year, as you would all know, and then we've got our core courses in levels 2, 3 and 4, plus a minor stream, and I'll talk about the different minor streams in just a second. I'd also like to highlight our industry placement program, and I'll talk a bit about that in a second as well. And we also have substantial opportunities if you're doing well to be able to study abroad for a semester. Okay, so what do we do? These are our core courses in levels 2, 3 and 4, starting off with chemistry and mathematics and thermodynamics and fluid mechanics. We also have, and that's not listed here, a bio-nano course in second year. Then going on to heat transfer and heat exchangers, reactions and reactor design, mass transfer and control of processes. Detailed design. So we have 2 separate design units, one in third year and then a major design project in fourth year. The design project in fourth year is a 12 credit point unit, and you'll be working in groups of 6 and working extremely hard to develop a complete process across the course of the semester. Yeah, everyone who does this says it's one of the hardest things they ever do, have ever done, but is one of the most rewarding at the same time. Also study management and economics, and there's a research project in the first semester of the final year. So, we also have electives, a minor stream. So these are 3 courses across the 3rd and 4th year in a biotech stream, a sustainable processing stream, and nanotechnology. So the biotech elective stream contains 2 Chem-Eng units and the BCH unit. So biotech is a growing employer of chemical engineers, and this will give you some more detailed information about the biotech area. So you're using biological processes for commercial industrial applications. So one of the things that you might be doing as a chemical engineer is, okay, so they've developed a process which can produce something on a very small lab scale. How do you actually scale that up so that it can produce commercial quantities? Yeah, and there's all sorts of issues that you might find when you're going from a benchtop test tube to kilograms to tons per year. Next, sustainable processing stream. So we've got a couple of chemical engineering units. These are focusing on how do we run our processes better. How do we reduce our energy consumption? How do we reduce our water consumption? How do we apply the principles of sustainability? Training in life cycle assessment, looking at process changes that you might like to make, and then seeing, are these actually going to be a net environmental benefit? A good example of this is, well, I guess something that I do, which is around water treatment. You might think that always that treating water to a higher standard might be a net benefit. But if you think about it, it actually takes more energy, more chemicals to treat your water to a higher standard. And so you actually have to assess whether there's going to be a net benefit from doing that. Maybe the effluent which you're treating, the environmental disadvantages weren't that bad. Next, nanotechnology stream. This is a brand new area, and people who are working in this are often going on to develop new materials. So, what are some of the options and the opportunities that you have in this course? Well, exchange program scholarships. That also is in some of the other engineering departments, but I'd also like to highlight this integrated industry experience. So this is unique in chemical engineering. What we have is in the final year, first semester final year, we've got one 24 credit point unit where you go away for 4 to 6 months and do a project in a company. And so it's integrated into the degree. You'll get a mark for that unit, but it gives you in-depth experience in working in an industry that you're not going to get if you stay here and do the research project. And basically it's going to give you a real leg up. So other things you might like, well, community atmosphere. We've got the Society of Monash University Chemical Engineers. We've got weekly industry speakers. And I would say that the staff and the students get to know each other very well. Okay, that's it. Thanks.